Good morning, everybody, and welcome to MetalCon Live. Today's session is proudly brought to you in partnership with the Air Barrier Association of America. And today's session is called The Big Disconnect, the importance of wall-to-roof connections for the air barrier. This is presented today by Roy Shuffle. The Air Barrier Association of America is a nonprofit trade association and the national voice of the air barrier industry. ABAA has actively raised the quality of the industry through a quality assurance program. To find out more about the ABAA and to get certified, learn more about the association or anything else to do with air barriers, check out their website at airbarrier.org. It's also on the screen right here. Mark your calendars for the next two upcoming MetalCon Lives. February 22nd is going to be a successful management of metal roofing projects presented by Todd Miller of AIA Industries and one of our favorites here at MetalCon. We also have March 22nd, a very special program with MetalCon Live, and it is going to be designed for the future leaders and new members of the metal construction industry. This session is called Decoding the Language of the Metal Construction Industry and will be presented by several individuals from this industry. Be sure to mark your calendars for that and make sure you tell your future leaders and your younger professionals about it. Our call for presentations for MetalCon is now open. If you have any ideas on potential topics or any potential courses you already have, please feel free to submit those to us and we'll review them and let you know in the very near future. You get tons of perks by being a speaker at MetalCon, and we'd be happy to share this with you. If you have any questions, you can always reach out to me. I'm Kaylin at kaylin@metalcon.com. Registration for MetalCon will be opening up in the very near future. So please check back for more information to attend MetalCon as a general total experience or an architect's experience attendee. If you want to be an exhibitor at MetalCon, you can reach out to Mark Swaggerty at mark@metalcon.com, and he'll be sure to reach out to you with additional information. If you run into any technical issues, have any questions, please feel free to reach out to me in the chat box and we will be happy to connect with you. Also, be sure to fill in the form at the end so we can ensure that you receive your certificate of attendance. If you're a member of the AIA and have submitted your AIA number into the registration for this session, we'll be sure that your credit is applied for promptly. Without further ado, I'm going to hand this over to Roy. Roy, you can take it away.
Hi, thank you. Just do the share screen bit.
There you go.
And we should be good to go. I want to thank everyone for coming to the presentation today. Your attendance is deeply appreciated. And I think full screen there. We're good to go.
Good to go.
Well, thank you, folks, once again. And I'm going to give it to you straight from the shoulder, what's going on in our industry, what's going on and what you need to do and how to work with the architects to get the right roof-to-wall tie-ins. The Air Barrier Association has a very strict code of ethics, which I will be adhering to throughout the presentation today. I will not be able to answer anything of a proprietary nature during the presentation, but I will be able to answer them afterwards. As always, we have a Q&A section. You can type in your question, and I'll do my best to answer all the questions by the end of the presentation. This is a copyright of the ABAA itself, and it is registered with AIA, so all things are good. But what this slide is showing you is that the Air Barrier Association went to all the trouble to get this properly registered with AIA, and the second paragraph just basically denies whatever I'm going to say. The course description is very, very straightforward. Been a lot of changes in our business since the adaptation or the adoption of the IECC 2015. Air barriers are required in most, if not all, jurisdictions throughout the United States. There are some areas that do not require an air barrier, and they would be known as Climate Zone 2, B as in beta. But the vast majority of the United States now has air barriers as a mandatory requirement in their building code. And baseline for the LEED program is an air barrier incorporated into your building. One of the areas that we deal with in our side of the business is how to tie all these things together. There's an awful lot that goes into that, a lot of engineering, A big issue that we deal with is chemical compatibility. And I will cover off on some of that for you today. I will make the chemical compatibility issue very easy for you. It's not going to be some long, boring talk on chemistry. So we're going to go at everything from a design viewpoint and a contractor's viewpoint to make these things more easy for you and to make them constructible. I see many drawings and many details that really look good on paper, but they're not constructible. And that's a portion of the business that we continually try to improve. So number one learning objective, believe it or not, mention it again, become aware of the compatibility issues between the roof and the wall and your waterproofing in the wall. Understand the importance of the roof wall air barrier. Understand the integration of different types of air barriers into the roofing assembly. Now, the good thing for me is many of the MetalCon folks, you're dealing with metal. They're pretty inert. But some of the underlayments that you go with on a standing seam metal roof may require a little bit of a different attention. And we'll go over some basic requirements for detailing and sequencing the roof to wall and the wall to waterproofing tie-ins. Understand that I will be giving illustrations at the end of how this can be done. These are not the only ways that it can be done. And I am a certified air barrier specialist, one of 23 in the United States of America. You're always welcome to give me a call with your questions. My contact information will appear on the last slide. Everyone thinks that the Air Barrier Association of America deals strictly with air. Well, we have a program called the AIA Evaluated Assemblies, and there's a variety of protocol testing in there, of which 50% is moisture, water not getting into your building. So half of our protocol testing to become an evaluated and listed assembly is water testing to ensure that we don't get the lawsuits for the leakage. Water entering a building is roughly 65 to 70% of the lawsuits in the construction business. So for the last 20 years, we have worked very, very hard to really minimize this potential problem from occurring. Let's take a look at what we have to deal with. And if you're a design professional attending this seminar today, understand the myriad of things that you need to look at and what's out there. We basically have three types of backup walls: CMU block, OSB/plywood, or exterior sheathing, normally exterior gypsum sheathing, but there's some market movement now for magnesium oxide boards. They've all been thoroughly tested. You have five types of air barriers in today's marketplace. You have fluid applied, self-adhered, spray foam, board stock, mechanically fastened. Continuous insulation is required in many of the codes nowadays, especially over steel stud construction. It's almost mandatory. So what are the four types of cavity wall insulation that goes over your air barrier as continuous insulation? Again, spray foam, EPS, which could stand for extruded polystyrene or expanded polystyrene. Expanded polystyrene is the white bead-like material normally used with an EIFS system. And the extruded polystyrene has been around for many, many years. And you would know that by its color of pink or blue or green. You have foil face polyisocyanurates, very high R value materials, excellent materials for fire resistance. And you have the mineral, rock wool, stone wool type of products, fibrous materials made out of inorganic material. Add to that your four types of cladding: brick, metal panel. Know that y'all are big fans of metal panel, EIFS, and cement board. This would also include limestone and stone, natural stone, or even faux stone. But on this one slide alone, if you're a design professional, you've got 116 different wall configurations to choose from. They're all good. They all work. They just may not be the best for your project or for your design intent. Doing the math here, if you take a quick look at the number of manufacturers of air barriers nowadays, It's not that high. It's about 38 manufacturers of air barriers. And within each manufacturer, they have little tweaks and turns in their product line offering. This is far better than the single ply roofing industry back in 1981. I had the pleasure of being the first technical director of the Single Ply Roofing Institute. And at that time, there were 118 manufacturers, suppliers, or private labelers of single ply roofing. We only have 38 here in the air barrier industry. So it's a little bit easier, a lot more cleaner, as are your choices of technology. Roof to wall connections. I am pleased to announce that we've done a really good job on this, but I want you to also realize that we just went through those 116 wall configurations. Now you've got to take a look at your 16 different types of roof materials that are out there. And that just continues to add to your burden constantly of decisions and choices. ABAA offers a variety of learning units. We have what is called a learning unit cafe, where you can go online, look at the cafe, learning unit cafe. It's a little bit humorous. It's in the shape of an old diner menu, and you can pick and choose from the courses that you want to help address some of the issues you deal with in the field. But at this time, the ABAA has all roof to wall details in 2D, downloadable, no charge, downloadable drawings. And we should have the 3Ds up, I'm going to say by the end of March, beginning of April. So you'll be able to go in and take a look, see what you need for your project, and be able to design from there, or in the case of a contractor, construct from there. Or in the case of a material supplier, you'll be able to go in and make sure that the systems you're using and recommending are in agreement with the ABAA. And we could actually have a pretty good conversation afterwards if they're not in agreement. We're very open to having that conversation. So why is it so important to have a good, tight roof to wall connection? Well, building science tells us so. And I'm going to go into that in a few moments. But it's a significant area that causes air water leakage. Windows are the #1 area. Between the windows and the roof to wall connection, they're the largest holes in the air barrier system. And I always like to kid around a little bit with the architects. We build walls and then we put holes in them, and the holes are called windows. That's what we do. So we as an industry are trying our very best, and very successfully, to minimize any leakage problems around those window areas. It's just interesting to note that the #1 area, according to Zurich Insurance, is for lawsuits would be something like foundations for residential. #2 is water entry into a building, period. And creeping up on the top 10 hit list for lawsuits is sound control. With the advent of all of our multi-family buildings, multi-use buildings, sound control has really been a problematic area. And while it has nothing to do with the air barrier, I just want to share that information with you because our industry is always changing. Our problems are always changing, and we're going to be chasing things for years to come. There are only two purposes for an air barrier. One is to reduce airflow, either into or outside of the building, and reduce moisture and water migration. We don't want liquid water entering into the building. We certainly don't want high humidity moisture vapor entering into the building. And things have changed. In the 2015 code, in addition to air barriers being mandatory, so was continuous insulative sheathing. And the reason the continuous insulative sheathing came about is after years of study, we found out we had been instructed by the federal government incorrectly. The mold and mildew problem came about in the late 90s because of some of the prescriptive mandates handed out by government. For instance, a typical steel stud construction with R13 in between the studs only had an effective R value of 6.0. And in that regard, there really were very few buildings built up to and including about 2000, turn of the century, that actually met building code. When they looked at the thermal leakage through the steel stud, they realized they needed to have that continuous insulative sheathing on the outside. With the advent of that continuous insulative sheathing, we now design buildings that have a true R value of R13 or whatever in the cavity wall. Much more thermally efficient buildings. The air barrier by itself does indeed save 40% of the energy cost just by preventing the exfiltration of air from the building. If the conditioned air, which you spend a lot of money to condition and dropped into your building, you want it to stay in your building as long as is humanly possible. If it exfiltrates rapidly, you're going to have to rerun your equipment and make that air up, spending more money in the process and creating a lot more greenhouse gases. Our building science has also told us that we have a lot of effects on our building when the wind blows. We have the airflow or stack effect, where the pressures are huge at the top of the building. And most wind speeds in this country are measured at 30 foot building height. Why? The numbers indicate that 85% of our buildings are at about 30-foot building height or below. The high-rise buildings, the multiple story buildings, present a little bit of a different problem, but the physics is the same. No matter what height your building is, you're going to have a neutral pressure area. You're going to have a negative pressure area, which is normally closer to ground. And at the top of the building, no matter how many stories up, you're getting an increasing positive pressure at all times due to stack effects and wind effects. This illustrates beautifully what I have said. If you have a low slope commercial roof, and low slope to me is anything 2 inches per lineal foot of run, 2-inch slope per lineal foot of run, you're probably going to have edge details that you have to pay very close attention to. On the left, you see an extremely low slope commercial building, a 1/4 inch and 12 slope. And normally this can be a single ply type of roof, modified asphalt. But when the wind blows over that building, you have a couple effects going on. You have the wind creating a positive uplift pressure on the building, but behind that parapet wall, you're going to have a vortex effect with much higher uplift pressures. The parapet wall normally acts like a airplane wing. It's a Bernoulli or Venturi type of an effect in that area, increasing the uplift pressure. Most roofing systems peel back from the edge. This is because of the positive pressure and sometimes the airplane wing effect on the edge of that building, which is why if you look at the factory mutual requirements, you'll see that you might have a requirement of a factory mutual 1-90 or 90 pound per square foot uplift fastening pattern for the edge, for the field of your roof. But when you go to the edge of the roof and the corners of your building, you might have a factory mutual 1-120 or 120 pound per square foot uplift requirement. Again, the edge effects are pretty stout in all these things and do lead to a lot of premature failures in wind generated events. The slide on the right can illustrate best why we're talking about roof to wall connections. In this particular building, way up north, and by way up north, I mean up north. I'm a native of the city of Philadelphia, Pennsylvania. I now live in San Antonio, Texas, and climates are different, effects on the building are different. But the slide on the right will show you that there is not a good tie-in between the roof to the wall and the warmer, moist air inside the building is exfiltrating during the wintertime to where you do have condensation on the outside of the building, and in colder climates, significant ice buildup. Additionally, it's costing you a ton more money by having to add to that exfiltrated loss. You have to recondition air, put it back in your building. So you're constantly spending money to keep that inside building environment at a reasonable level. You're also creating a lot of greenhouse gases doing that. So this is very, very common occurrence. you need to pay close attention to these roof to wall details. So we have the wind effect, we have a stack effect, we have today's buildings, combustion and ventilation. And when we had the original mold problem back in the 90s, a lot of people said we were building our buildings too tight. Well, nothing could be further from the truth. We were building our buildings too in the middle. There was a lot of science we didn't understand. There was a lot of science we didn't have the ability to measure back then. But we now know these events can occur. We now know how to prevent them. So today's buildings, when you look at an air barrier just doesn't fit on the wall. We consider the air barrier to be the entire 6 sides of that building, which again is why the waterproofing to wall tie-in and why the roof to wall tie-in is so critically important to achieve the conservation that you wish, to make that building very efficient as far as the building owner's dollars are concerned, and to provide a great indoor air environment. Air either wants to be pushed in or pulled out, depending on the climate, depending on where you're at. You know, humid is going to move to a less humid area. You know, cold air is going to want to move into warmer air. So you have this constant battle, and the air barrier is the barrier between those two, climate events. And it's there to be the guardian and the protector of that building. So when the wind pushes on the building, we have that problem area because the wind will create areas of high pressure that will magnify both air and moisture flow to the top of the building, to that roof edge detail. There are some commonalities with air barriers that folks always want to talk about. Number one, you want your material to be liquid, water, impermeable. And as I stated earlier, part of the ABAA evaluated assemblies that we list online for the public's review is to make sure that we have done all the appropriate water testing. And that testing comes in under hydrostatic pressure, under different driving mechanisms. Self-sealability is another characteristic that we look at. There's a variety of architectural testing that goes into a roof, into a wall air barrier, not just, a couple physical properties. It's the whole gamut of what we know needs to be tested to provide the design community and the contractor with the safest, most robust materials we can get on that wall. Because once we get it on the wall and put the facade on, Katie, bar the door. We do not want to leak anywhere in that building. So key issue, liquid water impermeable material. 2, it must be continuous. So that's why we're talking about the roof to wall tie-ins today. It's got to be continuous to handle the 6 sides of the building. It's got to be strong. It's got to resist positive and negative loading. And the testing protocol for this for air barriers takes it up to about a 99-mile-per-hour wind, positively and negatively on both sides of this wall assembly. And that is to accommodate the wind pressure blows on the wall. It's high pressure. The backside of that building is going to see a negative pressure. So the air barrier's got to be able to hold both. And it has to be durable. Normal design life here in the States is about 40 years. That material is going to have to last 40 years and perform well during that period of time. Compare that to a roof. And let me make myself clear. A roof membrane is an air barrier material. A standing seam metal roof is an air barrier material. So there are different levels, I'll get into that in a moment, of air barriers that you can have on your building. But taking a look at this, this will illustrate how things have changed. What are the common key requirements for roofing? 1, liquid water impermeable membrane. 2, it must be continuous or it's not going to be waterproof. 3, it must resist strong positive and negative loads much higher than the wall air barrier will see. And it has to be durable. This is why a lot of the designers specify a 20-year no dollar limit warranty. The roofing membrane exhibited here happens to be a mechanically fastened or mechanically attached roofing system. This was a patent of mine back in the day, as one would say, before the turn of the century. But this type of roofing membrane nowadays may cause a problem on your building. Why? In cold areas, that little billowing between the fastener rows can pull up that internal air, that conditioned internal air, to the backside of that roof. If you're in a very cold area, that could cause condensation. And if you're in a really cold area, you could get pretty, ice formation very, very quickly. And, my beautiful little baby here, as I call this roof assembly, probably isn't as desirable as it used to be in certain climatic conditions. So everything changes. And our business has changed drastically since like 1980. So there are 3 ways to get code compliance for an air barrier. Excuse me. And this all started with Chapter 4 of the International Energy Conservation Code 2015. So you have the material, you have an assembly, and you have a whole building air tightness. Now, what's interesting about whole building air tightness, this is where you pressurize a building. And right now, testing protocol for the state of Washington, soon to be Oregon and California, they're making it mandatory in those codes, those state codes, to turn around and have whole building air tightness performed on all buildings. Mandatory. Excuse me, folks. Material and assembly, they're a little bit different, but just understand what's coming your way. 3 parts of the code. Material, ASTM E as in Echo 2178 is a material test. Very low pressure, 1.56 pounds per square foot. It's on the materials only. So you take a 2-meter square piece of material, put it up in a test frame, and test it to see what its air leakage is. A variety of materials listed in the code, roughly 15 of them, already meet this. 1-inch thick rigid foam insulation will meet that requirement, as will plywood, some OSB, stucco coated block. There's a variety of materials that will meet that. Then there's the assembly test, which is the test that ABAA uses to come up with their evaluated assemblies. It's a full-scale wall test, 8-foot by 8-foot wall, joints, faux window, wall ties. Folks, I apologize for the coughing. So this full wall assembly is tested to that test. That's the one that positively and negatively pressurizes the building at 99 miles per hour. Several hundreds of cycles go into that. But again, you can see what meets it. The building test, the ASTM 779, that's that whole building air tightness testing, which is mandatory in 1 state, soon to be in 2 states, and will probably travel east after this. So what are you looking at in the business for air barriers? There's a lot of them out there. As I said, 38 manufacturers. The business started in the late 1990s, early 2000s, predominantly with the self-adhered membranes, 40 mils thick, self-adhered polymer modified asphalt. It was followed by the fluid applied membranes, very much so, taking over good market share. A lot of people had spray rigs for putting dam proofing on buildings, and they were able to adapt that capital investment to put on fluid applied air barriers. Sprayed polyurethane foams came into being, and now you have board stocks, building wraps, and sheathings with pre-applied membrane. I'll describe these very briefly. On the left, you see a rigid foam board, an insulating board going on to a steel stud assembly. And with that, you will attach that directly to the steel stud. No need for exterior gypsum sheathing. You're going to have fasteners. You're going to have tapes for the seam. All of those things are tested by ABAA. Also, with what's there, do recognize that this foam plastic insulation type is not going to help you with the torquing or twisting of studs. So you do have to put C channels between those steel stud and the cavity wall area. So it's just not as easy as it looks. And sheathings with pre-applied membranes are materials manufactured in a controlled environment in a factory. And that factory will have a gypsum board or a plywood board to which they'll apply an air barrier material. And then that pre-finished product is shipped out to the job site for erection. This is a good method of lowering labor costs, but in some markets, it does cause a little bit of a problem. And the problem comes up because you have union jurisdictions that argue back and forth and sideways. It's a growing segment of the market. It allows you to construct buildings over the wintertime where otherwise you may not have been able to, but it does cause that union jurisdiction.
Hey, Roy, we actually have a question that has come in regarding some of your most immediate slides. Do you mind if I read that out to you?
Sure.
Great. So tying in a component of the vapor drive and the effects it presents in conjunction with air, has it been indicated thus far?
Yes, it has not been. And the questioner has jumped a few slides ahead, but I'll address that now. Way back when, vapor permeance was a big issue. And it was a big issue in the food packaging industry. So we run a test called ASTM E as in Echo 96. But that test came from the food wrap industry. Somehow it morphed into the architectural and construction industry. And it was a concern up until the advent of the continuous insulative sheathing. And here's the reality. In today's building code, in the IECC and definitions, no one's calling anything a vapor barrier anymore. They're all vapor retarders. Additionally, the marketing, how do I say this? The marketing language of breathable or non-breathable or permeable or impermeable is no longer used. In reality, everything is a vapor retarder by code, class 1, 2, and 3. The same testing applies, ASTM E96, but they have broken it out by levels of vapor permeance, and that's how you design. But if you're designing with a foam plastic insulation, I can assure you that that foam plastic insulation is indeed a class 1 vapor retarder, or what we used to call a vapor barrier. So if you're designing using, God, this is awful. You're designing using vapor permeance or perm ratings, it really doesn't have the importance that it had a few years ago. It has a lessened importance because of the advent of the continuous insulative sheathing. And I hope that answers the question. If it doesn't, I'll answer it again.
Perfect. Thank you very much.
You're welcome. The reality of construction, I'm in San Antonio. We're only 150, 160 miles from the border. We see some very creative designs and workmanship down there along the Rio Grande. This is one of them. You can see the large gap between the steel roof deck and the CMU wall. Additionally, you can see that the mortar is not, flush with the wall on the CMU. And in some places, it's not even there. So the reality is we've got to accommodate that. CMU joints mortar joints should always be struck flush. And we should have a good working surface for the air barrier. If this were my project, I would have rejected that wall. But it's not my project. It's here for illustration purposes only. Other things that we run into. This particular air barrier being shown is an excellent air barrier. It's been on the market for 20 years. It's performed very, very well. But you can see how unsightly it is. And I will tell you, this is a position paper from the Air Barrier Association of America, downloadable online. If any material going on that wall says it's self-adhering, it must be hard rollered in with a silicone roller or with a stainless steel roller. The wrinkles you see, I can tell you this particular project, they hand pressed the materials onto the CMU and did not get full adhesion. And in time, they bow out like that. They gave you what's called a tunnel blister. Had that been hard rollered in, you would not see that. At the bottom of this wall, you see another instance of where we have problems in the business. This is where the through wall flashing portion of that wall was awarded to the masonry contractor. So the GC wanting his building to be done quickly and dried in quickly required the air barrier manufacturer, the air barrier contractor, to put his material on first and then come back with the through wall flashing through the masonry contractor. Well, you can see that number one, it's not fully adhered. Number two, it's a heck of a fish mouth there. Number three, that is a leak waiting to happen. So, scheduling is a tough part. I have some recommendations for you at the end of this presentation, but this is what happens in construction. This is what we deal with. So any condensate or water going to that back wall is going to drop down and go in that fish mouth and into the building. Lawsuit waiting to happen. We call that a reverse slap in the fish mouth. Should not have been done that way, but it was. Fortunately, it was caught under the auspices of the quality assurance program by ABAA. And you've heard us talk a little bit about the quality assurance program. Most people ask me, what is the cost of that program? Because it's an on-site audit by third-party auditors. Normal cost is less than 0.03% of the project cost. And everybody gets a copy of the audit report. General contractor, project architect, building owner, manufacturer of the air barrier, and the contractor, the air barrier contractor. So no one escapes the audit look-see and subsequent reports. But this is just one of the many things we deal with. The reality of construction, we have gaps in our buildings. And here you have an instance where the steel roof deck is protruding over the wall. You've got to make your air barrier continuous. So your roof to wall tie-in in this particular case would require spray foam between the wall and the steel deck. And, spray foam comes in a can now. So you just go up there and touch it up. It'll provide a can strip or a transition strip to which you can apply your air barrier membrane and take it up to the underside of that roof deck. And you've got a very, very nice transition at that point. Talking about chemical compatibility, there are a lot of materials out there. Many of them are not chemically compatible. In this particular instance, you're seeing an oil of exudate or oil of incompatibility coming out of that wall. This was the case where an asphaltic air barrier from manufacturer A was put on that wall. And then the contract for the through wall flashing was awarded to the mason. And he went out and bought his flashing material, also asphalt based, from another supplier. Asphalts are not chemically compatible with each other unless they come from the same manufacturer. So if you have a product made from a Venezuelan crude that came into Corpus Christi, Texas, and was refined into an asphalt, and you had another product on that job site that's from a mid-continent asphalt made in Kansas City, they're not going to be compatible because asphalt has 4 main fractions and about 250 different chemicals existing in different ratios. So this is what you get. Anytime you see oil, be it clear or dark, on a job site, it means there are some incompatibility problems ongoing, and it could lead to a premature failure of the wall assembly. And if the wall assembly has a premature failure, you get the letters from the lawyers. This is what we do at ABAA. This is not the full chart at this time. It's being updated as we give this presentation, but it's basically a stoplight. Green means go, yellow means caution, red means don't do this. And you can see that a lot of the man-made material or synthetic material is not compatible with other man-made synthetic material because they all have varying amounts of different chemicals in them. What shows you in reality is the inorganic or metallic flashing materials are the most chemically compatible because they are chemically inert. And you can see the copper sheet metal, the copper fabric, the copper drainage. At the bottom, you see the stainless steel. They are chemically compatible across the broad spectrum of what's being used in the air barrier industry at this time. And because of that, they make excellent transition membranes between roof to wall and wall to waterproofing. It's just the way it is. Doesn't mean one's better than another. It just means be aware of this. This could be a problem. And this is a pretty big problem that we see in the business. So metal offers a lot of advantages. And in many cases, on an installed cost basis, it's the same cost as the man-made or synthetic materials. But take this chart to heart. If you're specifying, designing, or installing, this can save you a lot of time and trouble. There's still a variety of types of roofing out there. Fortunately, not as many as there used to be. The industry's down to a few, but there's still asphaltic containing materials for modified asphalt. A lot of fluid applied materials out there now for inverted roof membrane assemblies, the IRMAs, or the PMAs, the protected membrane assemblies. Those particular materials are normally used on plaza decks or on a vegetated rooftop, but you still may have to tie into those. Say if you have a metal facade building that has this type of structure on top for the roofing assembly, you still have to do your tie-ins properly, making sure everything is, number one, chemically compatible and fully tested. And there are a couple ways you can do this. If you are a specifier, architect, design professional, there's 3 ways you can call out for these products. The first way is you can specify proprietary nature products. And most folks don't like proprietary or closed specs, but you can call out for manufacturer A to supply the roofing, membrane to supply the cavity wall insulation, to supply the air barrier, to supply the waterproofing. And there are about 3 firms out there that can supply all those components. B, you can go with what your normal is, and normal being you have manufacturer ABC for your roofing, manufacturer LMN for your air barrier, and manufacturer XYZ for your waterproofing. But you're going to have to get letters of chemical compatibility amongst each of them. Air barrier to roof, roof to air barrier, waterproofing to air barrier to waterproofing. Or you can go back to what I was showing earlier with this type of slide and design your transition membranes and through wall flashings based on this. These materials, the metallic materials, don't have that reaction. So again, 3 ways to specify: proprietarily, or what you've always used based on your, familiarity with the product and longevity of the product and how well it's worked for you, but you're going to have to get letters of compatibility. Or 3, take a look at the metallic products. All 3 ways work well for you. It's just what's easiest for the guys for constructability also. These following slides are ways some people do it. The best way to keep incompatibility from occurring is to have a physical barrier between the 2 materials, between the air barrier and the roofing membrane. But even in this slide, this is done by Andrew Dunlop of the Smith Group. Andrew is this year's co-chairman of the Air Barrier Association. But note on the front of that detail, behind the continuous insulation at the top of the stud, there's still that area where they are physically touching. What do you do there? You get your letters of compatibility from both manufacturers, or you continue the air barrier up and over, put a strip of stainless steel or copper there, and adhere your roof membrane to that. You don't have a problem. Again, physical separation prevents chemical incompatibility problems. Chemical incompatibility problems only occur when the materials are in physical contact with each other. And just different ways that Andrew designs and does his thing. He's up in Detroit. He has other considerations up there for cold weather climate, as opposed to someone down here in San Antonio. So are these climate specific? A little bit. But again, I urge you to use the CABs people that are available to you in your area. Certified air barrier specialist. They are listed at the air barrier website at airbarrier.org. You can find them. I happen to be one of the ones for Texas. You're welcome to call me no matter what state you're in. Fluid applied roofing. We'll be wrapping over the parapet on this. Now, this happens to be the owner's building, and he is a manufacturer of air barriers, roofing membranes, and transition membranes. So he knows the chemical compatibility, but he does it a little bit differently, his choice. Again, asphalts, you need to get letters of compatibility between everything. Make sure of that. And we have had some problems with steep slope roofing. In Texas, we have a great fondness for using standing seam metal roofing on steep slopes. And that's a tradition brought over to this country by the large immigrant population from the mid 1800s of Germans and Czechoslovakians. We love our standing seam metal roofs here. But any steep slope roof can pose a problem, a little bit of a different problem than what we're used to. The connections for the air barrier need to be made at the ceiling level. And you must seal all the penetrations through the ceiling. Because with the changes in climates and construction, if you don't do that, this is what happens in colder climates. If you don't seal the penetrations, the warm, moist, conditioned air in the wintertime rises up into, lack of a better word, an attic space. It will condense, and in more severe cold climates, it will turn to ice. This particular building owner asked, what can I do? The only thing he could do at this point is scrape out as much ice as he could, turn around and wait for the first thaw, hoping that not much water enters the building. When the attic is dried out, he's got to go back up and seal all his penetrations. So again, make your connections at the ceiling level, and as critically, seal all the penetrations through the ceiling. You won't have a problem. You've contained that warm, moisture air in the winter from going up and contacting the colder air in the attic. Again, different details, different strokes, different ideas. To prevent chemical incompatibility, first pathway, you do not bring them into contact with each other. Second pathway, put something in between them to act as a transition membrane that is compatible with both materials being used. This is typical of a job site. This is just the parapet wall detail that I'm dealing with. And this could have been a metal facade, and this one happens to be a tilt up concrete facade. But I have 10 comments on that very small area. So I urge people to have a pre-construction meeting, not to make it critical, to make it mandatory. For the design professional out there, allow me to share with you who I want in that meeting. I want the GC, I want the project architect. I would prefer a CABS to be there, certainly the air barrier manufacturer. Who else? You want the roofing contractor, you want your electrician, you want your plumber, you want your window guy, and you want your facade installer. That's 10 people in that mandatory meeting. Why? Because every one of those other trades has the opportunity to put a hole in the air barrier material and violate the integrity of the air barrier performance. In that meeting, you need to figure out who's responsible for the scheduling or like another word, sequencing of the construction. And I'm sure you all like this. This is totally the GC's responsibility. It's not the contractors. It's not the architects. The GC must make sure that this is done. It lies on their footstep. Roof to wall, we know the different things leak air. We know the parapets are problematic, but certainly HVAC curbs and expansion joints and penetrations. But the testing protocol really gets us around all those big air leak areas. Roof to wall connection on the left, that's beautiful, perfect. On the right, not so good. Again, great materials, both of them, but you can see where the self-adhering material, which the one on the right is not hard rollered in and is not sealed. It's got buckles in it, blisters, fish mouth, and parts of it are unadhered. Again, a lawsuit waiting to happen. Different details, different ideas. None of them are perfect. All of them need a little help. Roof to wall guidance that we can provide. We do have guidance online at airbarrier.org. But when you're looking at a roof, understand that a roofing system is an air barrier material. It's made up of multiple components that are air barrier materials. So you're always looking at different things on your rooftop. Here's a full wall, masonry facade on this one. A lot of detail has to go into this, and just be assured of everything you're doing. Again, you have several layers of materials on the roof that are an air barrier. How air barrier material based on ASTM E as in Echo 2178, which is acceptable by code. So you can see different things coming back and forth and tying into each other throughout the building envelope. This is a perfect detail of how that steel deck to wall was done. Spray foam, continue the liquid applied membrane up to and underneath that steel deck, the roof deck. Perfect. Absolutely perfect. Spray foam, taking a large market share. All the same details as you do with everything else. All your connections are made at the roof deck level at some point. And how you tie it in is entirely up to you. But a word of caution, if you're using spray foam behind a metal facade, you do need to be aware that spray foam can be exothermic, i.e. build up heat during the process of curing. If you have a thermoplastic flashing or transition membrane, thermoplastic is easily deformable by heat. Polymer modified asphalts, PVC sheets, all those are thermoplastic materials. The metallic materials aren't thermoplastic, they're thermoset. They do not get deformed by the heat. So you try not to build in premature failures into that assembly. Good detail of a spray foam job, good transitions. And this is the other side of that building that I showed you earlier, the owner's building. This is the opposite wall. These are how these things are brought into contact. All the materials on this wall are being used by him because his building, he's the manufacturer. So what you want to identify in your drawings is your water control layer, your air barrier layer, and your vapor retarder layer. Critical elements to define, make sure they are continuous. You can do a lot of that in that mandatory pre-construction meeting with all the folks in there to decide who does what and when they do what. Another consultant, John Straub, just a different way to do all these different things. Your world has become more complicated. Our entire world has become more complicated by our drive towards better buildings, better indoor air quality, and just reducing the greenhouse gas effect. These details are not universal. Each consultant that I deal with has their own ideas, but look at that chemical compatibility issue, look at the continuity issue. Always, always, always looking at all these things, just different ways to do it. We at the Air Barrier Association stand by, more than willing and able to help you with what you're doing. We're available. Use us. We don't cost anything. We want to keep our industry out of trouble. We have regional advocates. I'm also one of those. And as importantly, CABS, the Certified Air Barrier Specialist. It's a very high rated program. It is ISO 17024 rated. The federal government Department of Energy, they recognize this certification. There's a lot of certifications out there that they don't recognize. This is one of the few that they do recognize. And you can find a local CABS at the Air Barrier website. So, summary, careful detailing in your drawings. If you're not sure, get someone to help you. Number two, understand the chemical compatibility between roofing membranes, air barrier membranes, and waterproofing membranes. And most importantly, as I illustrated throughout the presentation, sequencing of the construction is critical. And there you have the final of the presentation. I got it done on time, in spite of my coughing. You have my contact information there. you're welcome to call or contact me at any time.
Absolutely. That's awesome. Thank you so much, Roy. We do have a few questions coming in from the audience. And if anyone else has any questions, please feel free to submit them either to the Q&A section or in the webinar chat. The first question that I have is coming from Frank Rosario, and it is, do fasteners that penetrate the face of a WRB/AB insulative sheathing board compromise the barrier nature of the air movement or pressure drives?
Most people that ask that question are more worried whether the air barrier is going to leak once you penetrate it. And the answer is probably not. We have a research program ongoing at this time to test all of that behind continuous insulation. But please understand, one of our critical tests that we run for all air barriers is the fastener sealability test. And that is where you basically have a hydrostatic head on the fastener, which the fastener never sees in a wall application unless there's a flood. And since we're not waterproofing, we don't pay all that much attention to it. But yeah, you could have a little problem with thermal bridging. A lot of people speak of that, but we do test for that fastener sealability through the wall.
Awesome. Great answer. I also have a question regarding how the physics have changed since the year 1980 when it comes to the air barriers of a building.
The physics have changed because we know more. We didn't understand all the physics early on. We finally got a handle on that steel stud R13 only being an effective R value of 6, which meant in most climates the dew point was inside the conditioned space. The physics itself are more well known. I shouldn't say they changed, but our knowledge and science of the building envelope has changed tremendously in the last 40 years.
Wow.
And at my age, I'm old enough to have lived through it.
Well, that's awesome. I do have one more question. Oh, never mind, I'll take care of that. So I do not have any further questions, and I appreciate you presenting. Thank you everyone for being here with us today. We appreciate you coming on, joining us live. And if you're watching us in the future, please feel free to reach out with any further questions that you have. Roy's information is listed on the screen here, and you can always reach out to MetalCon. My contact information is kaylin@metalcon.com. Thank you again to the Air Barrier Association for partnering with us on this presentation. For more information on the Air Barrier Association, please feel free to go to their website, airbarrier.org. And if you have any questions or want further information about MetalCon, please feel free to go to metalcon.com. Thank you so much again, everyone. Special thank you to Roy for joining us today. We look forward to seeing you all in future presentations. Thanks, everyone. Have a great day.
Thank you all. Appreciate your time and attention. Bye.